Hey everyone. A student asked me at the end of today's class whether or not we could use the same arguments about distinguishable strings from the DFA case to lower bound the number of states we need in the NFA case as well. So it turns out that this isn't true, and in fact, NFAs can be much smaller than their equivalent DFAs. But I wanted to take a few minutes just to explore why the previous argument fails. So if you remember, this distinguishability argument relied on the fact that if we could find a y such that one of x1y, x2y is in L, then we would get a contradiction, because this would mean that on following either x1y or x2y, we would reach a state that had to be both final and non-final. So why doesn't this argument also work for NFAs? Recall the NFA here that we saw in class that accepted the language the third last character is 0. So let's look at two different strings. x1 is 0 and x2 is 0, 0. Neither of these are in L, however they are distinguishable, because if I let y be, say, 0, then x1y is not in L, but x2y certainly is in L. It's not too hard to see that both x1 and x2 can reach the state q1. x1 by just transitioning, x2 by first looping, then transitioning. And yet, there's no contradiction. So what went wrong? Well, remember in the DFA case, the key point was that x1y and x2y had to reach this state over here, which then forced that state to be final and non-final. If we look at the analogous picture for the NFA, after reading in y, which is 0, we transition from q1 to q2. It's not forced to be final. Why not? Because of non-determinism. Sure, one possibility for x2 was that it ended up at q1, but another possibility was that it ended up at q2 by just transitioning twice. And this means that when x2y is read, it's possible to reach this q3 by making the right choices. If we look at the choices for x2 that lead to q1, all we've managed to prove by this distinguishability argument is that q1 just happened to be the wrong choice for x2. That doesn't rule out the possibility that there's actually a correct choice. To sum up, this distinguishability argument really relies on the fact that x1y and x2y are locked into one particular state. But this isn't necessarily true for NFAs, which can have multiple possibilities. Thanks for watching and have a great day.